Greetings and welcome to the Pure Report. I'm your host, Rob Luneman. It's time to bring the orange. And we are hitting episode 3 of our 15 architectural decisions. And it brings me great joy to welcome back Andrew Miller and JD Wallace to keep digging into these areas that I know everybody loves hearing about Pure. We will dispense with the traditional formalities with both of you and kind of dive in. We're going to be hitting 3 topic areas on this one. We're going to be hitting stateless controllers, a second controller, and something called limited error paths. So stick with us, because for each one of those, we're going to go into effectively what it is, and industry comparisons, how you would see this maybe on other platforms, and then why we did these things. What's in it for the customer? How do we look at that? You guys ready to go?
Let's do it.
I think I'm just hearing that we bring you joy, Rob, and that just makes me happy. So,
Any time I get to spend with you all, particularly in a room on video, is going to be joyful. All right. Number one, let us jump into, and this is one that actually we still talk about a reasonable amount, which is around stateless controllers, right? And around the controller architecture in general. But let's hit a quick, well, not even quick. Let's hit a quick around the technology. What is it?
So at core, this is the idea that there is no identity or state stored in the controller. And we actually see this in other things, like if you have networking background, for instance, that lots of data passes through a network switch, but there's nothing stored there as far as the data. You unplug a cable, you plug it back in, things start working again. This was actually very, very different from a storage array standpoint. So actually, I can feel myself going comparative, so I'm not going to go there yet. So it's the idea of the configuration is stored outside of the storage controller. This is the unique identifiers. We've done things to maybe even abstract away the WWPNs. We use things where there's virtualized WWPNs or IQNs, all the things that would actually identify the controller out into the hosts where the device is accessing it. These have all been virtualized in a way. Now, not virtualized like a virtual machine, but they're abstracted a layer away. So the core value is that if you take that controller out, you can put another one in, and it can look exactly the same. There's a lot more thought behind it, though, there, JD, I think.
Well, again, I'll go back. This seems to be my role in this podcast.
You are the historian.
Where's
your gray beard?
I remember those days as an actual, back-end IT admin, swapping out systems and literally having to go and pull out the drive on the controller where the persona was kept and making sure I got to move that over. And oh gosh, if it didn't work, now I got a whole new set of problems.
It sounds like a SIM card on an old cell phone.
And then you got to reprogram WWPNs.
Right.
There was
TFTP in and out.
There was so much work that was involved in essentially bootstrapping a new controller into a system where it didn't have any persona. And I can remember very long nights having to deal with some of those things. And so I think at core here, there's value to us and there's value to the customer. The value to us is if we've built an architecture where I can pull a piece out and stick a new piece in, that reduces our support costs. That reduces the likelihood of an error. But on the customer side, it also means that now we can have a lot more confidence in these components because each individual cog in the system is essentially replaceable.
It's replaceable. How much time did you spend doing that when you were an admin, when you would do those things?
That's how I grew the beard, actually. I didn't shave while I was...
Not the one you have now, but how much, seriously, how much time do you, hours? So like half a day. You just said...
This is not the kind of thing you would do...
Or what about at scale?
The prime of the day. This was a weekend after...
Oh, so this was a weekend over, because you couldn't do it while you were in production.
Or you might pay someone else to do it, because you didn't do this stuff very often. It was like, this was hard to do, and you didn't want to mess it up, and you had a change window to hit. So you might contract someone from professional services with a vendor or partner to come do it for you.
Is there a cost to that too?
Maybe.
Sometimes.
Just a little bit.
Maybe.
A lot.
Okay.
Actually, always.
Yeah.
Always.
Okay.
I'll stop being sarcastic.
Yeah. Okay.
The other piece here is that you think about when we talked about scale up, and for folks who are kind of playing the tape forward, playing the at-home game, they may think, okay, so a scale-up architecture, you're probably going to have 2 controllers for resiliency. And if you're going to ride Moore's Law, well, eventually you're going to have to replace those controllers, or maybe pretty regularly you're going to want to replace those controllers. So this is why decision 5, stateless, we're talking about now, and then we'll go to the 6th one, the second controller in a minute. This solves for part of that challenge. You know that you on a regular basis want to be in an environment where you can let customers easily replace a controller, either because, hey, hardware can go bad, that's one scenario, or because, hey, I want to put a next generation in, move between families, generations. Well, if I plan to do that not just as a failure scenario, but I plan for it as a technology migration, move to new generations of technology on controllers, I've got to pull all the state out of the controller to enable that for the future, kind of thing.
I think the core value here is conceptually, we want to be able to take all of the drives, all of the entities that store data, pull them out of a system, in theory, ship them across country, put them in a completely different system. And when it boots up, it now has the persona.
And it doesn't matter
of the
what the
original
the
system.
controller. You don't have to have that WWPN and that controller,
And
that
maybe it was-
identity, right?
Maybe it was even a different model,
Sure,
right?
sure.
So
And that I think I may bring it home here. So there were two pieces. One, you think about when Pure was starting, it was the era of Cisco getting into the server market, and they were bringing some of the ideas of statelessness that classically existed in network equipment. They were bringing that over to server hardware. And you had UCS, you had a profile, everything about the server identity was stored in the profile. That we actually still partner with Cisco around what we call FlashStack, because there's very similar statelessness in the server infrastructure as there is in the storage infrastructure. That's where part of why FlashStack is more than just a reference architecture. Comment for another day. There's other videos out there about
That's another podcast.
Yeah, it is. And it's actually one that we did. It's one of the first
It
ones
is
we did. Way
very
back.
early.
Man, going all the way back. But then also, this is why we have slides, actually, visuals that show not just like, okay, this customer had this Pure model and this Pure model and this Pure model and this Pure model. It's actually that it's the same system that maybe over the last 10 years has had 3 different physical controllers that were of different generations, and they can move to those based on the statelessness of the controller and pulling all the identity out of the controller. Now, there is the question, of course, is like, oh, that sounds like a lot of downtime and work. That is a teaser for the next one about the next decision about the second controller. Anything else you want to toss in, JD, before we go to the decision number 6?
no, I think that's a perfect transition.
Yeah. Okay. So you just queued yourself up, right, for the segue, which is okay, but I'll be segue guy, which I love to do. But how
Couldn't
does
help myself.
that then connect into second controller? And now we're getting into questions of active, passive, things of that nature, right? Which
standby, different terms.
standby,
Yep.
right? So lots of different terms that people are very familiar with, but talk about our evolution and what we learned about and what decisions we made in that space.
So I think I may approach this from an architecture standpoint, and then maybe JD, I'll let you keep being kind of history guy of how we got here. We figure out these are all.
It's kind of working out that
And we
way.
all tell the stories both ways, so it's fun. So you think about, okay, if we know there's going to be technology transitions, there's going to be new processors, there's going to be new backplanes, there's going to be new types of RAM that are going to be all the different things that go into the controller. Okay, fine. We want to transition to those over time. And you say, we want to enable you to do that more frequently and without impacting the business, which is a code word for without taking downtime. Because as soon as you have to take downtime for this stuff, you're into change windows, and you've got to, especially we talked about how you might run more applications on a Pure Flash array. Now coordinating the downtime for all those different applications, well, that sounds fun, and make it more like impossible potentially, depending on how many different departments you got to work with.
Yep.
And oh, by the way, we've also got this thing going on with this idea of the cloud, where you don't have to worry about any of this back end stuff, and you don't even know what the hardware is that you're running on, and you never take downtime with it. So if you look at a controller architecture and you say, hey, what if I could reserve the performance capacity of the second controller so that even when I go and do upgrades, there's no downtime and there's no performance impact? Wouldn't that enable an evergreen trademark architecture kind of thing? Now, there was actually a little bit of interesting story, JD, I think, of how we got there based on just being a startup and starting with a single controller. You mind helping me out there?
Well, let's be careful, because I want to make sure we separate front end active and back end active standby, because those are kind of two different concepts. So let's make sure we kind of close the loop on one. So front end, again, I remember the complexities of, okay, are these active paths, are these standby paths? And now if I'm going to have an active front end architecture in the sense that a lot of other storage vendors were thinking about, what it really meant was, well, half of the disks in the system were owned by controller A, and the other half were owned by controller B. And so I was able to kind of split that I/O. But now I've got things like trespass, which was a word from the old days of storage management. When a controller went down and it owned half of those disks, well, now I've got to trespass the ownership over to the other controller.
Various word for a technological term, really.
And
Because you're usually not supposed to access the other controller.
Yes,
bad,
yes.
except when it's all right.
Yes.
And so, again, this idea of simplicity that permeates all the conversations we've had, what if we just managed all of that on the back end and said, send me I/O down whatever path you have available,
Don't
and
worry
we'll
about it.
sort it out.
Mhm.
Don't worry about it. Every path is active. We've got enough performance in the backplane connecting these two controllers. If you happen to send it to a controller that can't do anything with it, it's okay. It'll forward it for you. And that there's actually incredibly low latency in that activity. And so there's really not demonstrable performance that's introduced or latency that's introduced as part of that. So front-end active-active makes life kind of easier for everybody, for the customer, for architecturally how we build this thing, kind of makes things
One
really simple.
fewer thing to worry about,
One
though,
less
right?
thing
With
to
these
worry about.
examples, when you were actually the practitioner, the example where we talked about stateless controllers and you having to go through that task, and now this is a thing that's in the back of your mind of, oh, well, I have to go worry about the moving things over here.
Or you don't even have to install custom software to handle the pathing. That
Exactly.
was well known. We're going to leave the name out because we're not taking pot shots. but
Everybody
you
loves
actually-
custom software.
You had to
Yeah.
go, and it was good for what it solved a need. But what if
Sure.
you didn't even need to have that? to
No, fix
understand
the
more
actual
complex
problem.
pathing?
Don't add software. Right.
Well, and if you had two different storage vendors that were talking to the same host, were those two different software packages going to conflict with each other? And it became a nightmare. But to answer your question, Andrew, so let's shift now. Let's talk about so front end I/O. Everything to the system is active-active, and we sort it out on the back end. We make life really easy. On the back end, however, we had a choice to make. Architecturally, we've got two controllers in every system. Do we want to maximize the performance envelope of the system by leveraging all of the power that's in both of those controllers? That was certainly an option.
Yeah.
And to be honest, I think in the early days, we probably considered trying to do that. And
It was a classic approach in the industry at the time.
it was. But what we said was, hey, again, remember, we're startup at this time. We got a lot of things to build, and we said we can get product out the door faster, into our customers' hands faster, if we start by not building that clustering software. If we say, hey, there's one controller at a time that's going to handle the I/O on the back end, and the other controller is just going to forward I/O to it.
Nope.
It was an easier architectural problem to get product out the door.
Yeah, we actually Pure started with a single controller system for applications where the performance was worthwhile and there's a different level of resiliency. And then when we first built the first two controller approach, we said, hey, let's take the approach that is the best time to market relative to value. And then we started to hear this really interesting thing from our customers about what they actually wanted.
Sure. So we actually, I think, considered for an amount of time,
Hot second.
well, now that we have it, let's go ahead and let's build that clustering and let's unlock the other half of the performance that's in the system. And customers said no.
Yeah.
And our SEs said no. We go, okay, why no? They're like, hey, if I'm thinking about the resiliency of my architecture, I need to know that there are going to be times where I only have one controller available. That's the point of having an HA pair. And I want my business to not be impacted. I want consistency when that happens. I don't want to get a bunch of phone calls from my internal customers that say, hey, something's weird with my application. Why did the performance just get cut in half? Oh, well, we were doing a controller failover.
Yeah.
You don't want to have those conversations. And so what we learned from talking to customers, they said, no, we're going to use it 50%. If you gave us 100%, we'd only use 50% of it anyway. So there's actually value in taking those R&D investment dollars and go putting them in other things that are more impactful to my business. We're only going to use half of it. Might as well give us that full benefit.
It's great feedback.
I remember a chart, actually, this is when I used to work with other systems. You'd actually see if you go past 50% of the total array performance capacity, you shouldn't be using certain features because if you have to fail over, it will cause very unpredictable results to various applications, et cetera.
Yeah.
The other thing that was happening kind of from an economic standpoint at the time was, let's think about, there's the term sometimes that you see, and you could Google on this, called COGS. It's basically the cost of the components that go into a system, any system really kind of thing. And so historically, when you looked at storage arrays, the higher part of the cogs was relatively in the controller, and the disks were relatively less expensive.
Mhm.
When we start to go to flash, we talked about the cost of flash relatively. So now suddenly
Things
the
around, right?
controller is a lower percentage, and even sometimes an increasingly smaller percentage of the total cost of the components. So let's think about good architecture. This even goes back to when I was on the partner side. Sometimes when you want to be kind of confrontational or get people thinking, you say like, okay, good architecture is about what do you waste? Or you could say, what do you optimize around? Well, in this case, does it make sense to optimize around getting the most performance out of a component of the system that is slowly becoming less of the total cost? No, you want to optimize around consistent performance. You want to optimize around the human side. You want to even optimize around the flash and getting the most lifespan out of that, not squeezing the last drop of performance out of the controllers at the cost of adding a huge amount of operational complexity. It's operational complexity we've taken for granted for a while because it's how it's just always been. We've lived with it, but that doesn't mean it was the right way to do it. And it was actually listening to customers say, no, we don't want you to keep doing it this way. It's
Yeah,
better if you don't.
it's less value there. It's interesting when you mention it that way, because if you do take a step back and look at the cost curve relative to microprocessors, right, the main components on controllers, those have come down in time. And then you contrast that to not the increased cost of flash, but the increased density, right, of flash being able to be utilized as components in systems, then that's where the cost goes up over time, which is super fascinating. And it is interesting, when I came in here, I had a microprocessor background and had some early meetings with engineering, and I was asking about the processors. They said, don't worry about it. You don't need to know. Well, what do we use? Whose brand? What model? This doesn't matter. That's not, like, we don't focus there, right? We just get whatever the latest and greatest is, and it's good enough. All right, we're focusing on all the flash stuff. JD, you had something to jump into.
This is the other value
Hmm.
that we extract out of that cost curve changing between the cost
right.
of flash and the cost of controllers.
Right.
Is now, if you say, hey, I need, and let's be honest, in this time frame, we experienced a tremendous amount of FUD from competitors
Absolutely.
who said, hey,
Particularly in this area.
you got a
massively.
controller over there you're not using.
That's why we're
right?
still spending time on this. It still comes up sometimes.
It still comes up.
But because of that shift in where the cost is away from the controller itself, what we realized was if we need more performance, we're already delivering more performance than most of our customers at the time were using. We could see that in the telemetry we got. And so what we said was, hey, if we actually need to increase performance, there's a lot easier ways I could do that than clustering a system and putting my customers at risk of inconsistent performance. I can add another socket or 2 sockets or 3 sockets to a motherboard and increase the performance that way. And many years down the road, or a few years down the road, we actually saw that come to bear with FlashArray/XL.
Yeah.
We've literally built a bigger mousetrap.
We needed to be able to have more cooling, to have bigger processors, and that's the path we went. And by the way, we actually still enabled non-disruptive upgrades from the 3RU FlashArray/X to a physically different form factor, FlashArray/XL, and that wasn't the first time we'd done migrations between different form factors. In the case, actually, FA420 over to FlashArray/M. That goes back to number 5, the statelessness. We didn't just say it; we actually had a track record around
M
this.
and X, one of those too?
Actually, we kept some of the same chassis.
The
in
same
there.
chassis, yeah. But then there were eventually some newer ones too that came into the mix.
The other piece here, I want to, we're wandering toward the end of this, and then
Sure.
we'll go to number 7.
Sure, sure.
But we're also linking back here to simplicity, because you were talking about the time at night that you might have to upgrade with stateless controllers, et cetera. But here now, this is if you're saying the system is going to keep track for you and not allow you to burst to a level that you will have a problem when there's a failover, planned or unplanned. Planned might be for a software upgrade, unplanned might be for some kind of hardware failure. Now you don't have to spend all this time tracking that level of utilization, and that dramatically lowers the amount of time that you're just sitting, basically babysitting the array. And that doesn't make sense at a human level to do. That's also one of the promises of cloud, if you will, historically. But bringing that, or actually in the case when we were offering this, it was even before some of cloud took out as much, but actually providing that same value. It's not a cloud value, it's a core infrastructure value of you have to manage and babysit the underlying components as much versus the system takes care of it.
And firmware upgrades too. Now that I know there's not going to be a change in experience, I can upgrade at any time. We still battle with cultural challenges
Correct.
to upgrading in the middle of a business day,
Hmm.
but those are problems we can solve. The technology is there to do it.
Supports it. Yes.
And there's even a classic case of science folks will start with, I'm not going to do any upgrades, software or hardware, except in change windows. Okay, and sometimes there are regulatory environments where it's required. And we'll commonly see customers, they go from, weekends and change windows to maybe after hours on a weekday kind of thing, because they start to get the sense of, just like on some systems, you more regularly upgrade the firmware even. Maybe think of it that way. It's not this hugely disruptive thing, or actually in this case, not disruptive at all. And we have published a 6 nines uptime officially, and that is without the cheat code of taking out planned downtime that everybody else does usually. Talk about, uptime. It's like, well, that's excluding when I plan to do the hardware
Measured
migrations,
thing.
et cetera.
Right.
We don't take that out because there's not the intent of having planned downtime on systems, even as you upgrade between generations.
It's one of my favorite questions when I get a chance to do a customer interview, like at Accelerate or just in general, if somebody stops by a booth at an event. Tell me about your first Evergreen upgrade, right? How long you been a customer? And invariably, it's always what you just
always fun. It's
described.
fun to hear.
There was one a couple years ago at Accelerate. Oh yeah, it was Friday night and 11:30 at night, midnight. Everybody was on call, ready. The CTO was ready to hear from us, and your team came in and did it and took off. And then the follow-up question: when do you do it now? Whenever we need to. We did one. The last one we
Thursday.
did on a Tuesday at 10:30 in the morning. Did anybody notice anything? Nope. Actually, there was one time we did it and we got a bunch of phone calls because whatever application user's app was running so much better, they thought something was broken, right? That's always a fun story too. So
This has also enabled a dramatically faster pace of technology and feature adoption,
for sure.
because if you have to coordinate, hey, I need more hardware, I need more capabilities, and there's new software, because new software usually takes more resources. Like we've added a lot of things with File over the last couple of years. JD's, your team, our team has been spending a lot of time on Fusion. There's new capabilities in the array, and they potentially need more horsepower than was available 5 years ago.
Mhm.
What a surprise.
Right.
But if you can dramatically accelerate and make that easier and non-disruptive to get there, you can actually have better features more quickly.
Bonus. That's right. Okay, let's hit number 7 and keep this train moving. Okay, this is an interesting one. I hit it up top, but limited error paths. Okay. What are we talking about here?
Well, I'll ask you a question. Where are 90% of the bugs in a software architecture? In the code that's only run 10% of the time.
Oh,
Is
really?
this like Pareto, 80-20, 90-10?
Oh, yeah.
So
Getting into bathtub curves. What's going on here?
So the idea here is anytime you have a bit of code that you've developed that you don't regularly exercise, it by nature isn't being tested as often as code that's in the normal daily execution.
It's in the
path.
core. That's fascinating. Yeah.
And I'm sure we've all heard it because we use this example so often, but it's so powerful. There's no power off button for the flash array. There's no shutdown procedure. Or
JD, what's the power off procedure for flash array?
go unplug it.
Boom.
And why is that?
It should be the same process for a planned downtime. You're moving it around, you're doing data center maintenance, whatever, as it is for an unplanned.
So why create another potential?
You have to in an enterprise system, you have to have the confidence that if you lose power, it's not going to lose your data.
Mhm.
You have to have that confidence. And I can, again, historian mode, I can remember that there were actually companies who say if you have a shutdown and you don't follow the proper shutdown procedures, you're going to have to pay a recertification fee. We're going to have to come, we're going to have to test that system. We're going to have to make sure that we can still stand by and support it
The data
because
integrity.
because you didn't shut it down properly.
Right. Whether it was your fault or not.
And whether it was your fault or not.
Okay.
And meanwhile, Pure's out there. We're saying, yeah, unplug the power cords.
There's actually a couple, there's a great example. This one I've got to relatively anonymize, where it is a large company where they actually had a data center level power outage, not related to us at all. And the Pure systems came back online within a couple minutes, 3 to 5 minutes, and then they start powering the applications on. The competitive storage systems actually literally took days to bring online. Like, this is still stuff that is actually relevant 10 years ago and is relevant now. Now the quote sometimes what we'll use, so I'll go in like official quote mode, is all code paths that are not part of the normal system functions are broken. And this is a little bit of like a Heisenberg uncertainty principle. We don't, if you until you actually check it, you don't know if it's broken or not, which means it is probably broken, but you can't check it. Or maybe Schrodinger's cat. I don't know. Help me out, JD. But maybe I'm stretching for analogies. We do this in other places in the system too. So there's the process around power off procedure. There's a special power off procedure. Also, as well, we talked a good bit about Flash, but man, there was more that we could have put in the previous episode around that.
Yeah.
One of the things is that any given time that you go to read a certain sector on Flash, it may or may not respond. Now, the vast majority of the time it responds, but it may actually sit there and wait for a little while based on what else is going on in the Flash die kind of thing. So we actually built the system so that every single time that you do a read, we actually try to rebuild from RAID. We're going to talk about our RAID architecture later, but in general, RAID gives you resiliency. We rebuild from RAID, and we try and read from the Flash, and we do a race to see which gets back first. Guess what that does to the level of quality and how much we exercise our RAID code? Insanely high, because we're actually exercising our RAID code that protects us against the nature of Flash not being as resilient in some ways all the time. The last piece that I may toss in is this was even, I believe, what the no power off procedure was one of the things that first led us into building some of our first custom hardware. So there's a fun Alan Kay quote about people that love software eventually make their own hardware. So before we even built direct flash modules, we actually built an NVRAM module. That was, we already had a capability with specific SSDs, but NVRAM module actually backed by supercapacitors was part of how you provided that ability of yank the power cables. And it was a more elegant way to do it at a better cost profile and more reliability. That the DRAM in the controller, where all the deduplication and the processing is happening, if you yank the controllers, we would actually drain the NVRAM down to the DRAM, which you lose when you lose power, down to NVRAM. And this was in the same generation as when there were systems that relied on built-in UPSs. And if those UPSs went offline, as happened with some platforms, you would actually lose data and have corruption.
Right.
So there's this whole kind of 2009 competitive layer to this, but this is also something that's pervaded forward for a long time as far as the philosophy of how we build the systems and even the simplicity of building the systems.
That's interesting because I mentioned on a prior episode the ESG lab validation, right? And the last time was in the context of just loading a bunch of different applications that run with different profiles. But as part of that lab validation test, right, they would come in, the third party would come in and they would pull stuff. They would pull out controllers. They would pull things. What's your resiliency? What happens? And that was always a really important part of that report for us because not Pure, but ESG is here and they're actually physically down in the lab pulling stuff out and then reporting on what happens, and we're staying up.
You can see the chart in my head. I'm not sure if we'll put it up as a visual, but actually it shows the latency spikes that are very, very small. I don't want to say unnoticeable, but when you pull a power supply, you pull a DFM, you pull a controller, and actually just the workloads keep humming along under load. It even goes to, I think this is actually now a couple of years ago, I was in a, I want to say an EBC, executive briefing for a customer with Kaz. And he liked to talk about, cables, fans, spinning discs. Those are the top three things that fail. And so things that don't move don't fail. And the fewer of those things you can have, so we have no spinning discs.
Yep.
And by virtue of having a dual controller architecture that's not scale out, we actually have dramatically fewer scenarios under which even the physical components can fail too. So that even drives up that 6 nines.
It helps that 6 nines. Absolutely. Good. Did we hit this one? Obviously, I think we've hit a lot of the value for the customer in this. It really is uptime, resiliency, confidence than we're using a pure system. You have to worry about a lot less, right? Particularly with some of the examples that you talked about, JD, from your practitioner experience. I think we kind of hit it.
And I think this is also why sometimes when working with, you're looking at, you may be someone out there who actually hasn't gotten Pure yet, and you're saying like, this is why often a lot of times somebody's customer references. If you sometimes have worked, and this is for me, I would ask for like a customer reference after I've evaluated something for 3 or 6 or 9 months kind of thing at the very end. From a Pure standpoint, some of this stuff, you want to understand it down the layers of how it works, but you also want to know just, is this true?
Right.
So often we'll see Pure sales teams, account executives, sales engineers, they'll pull in customer references, happy local customers far sooner because it's really, you care about the outcome. Like we're saying this is simpler and it's more reliable and I just want to talk to someone. And then over time, we'll actually understand all the pieces there, a little bit of being comfortable enough to take your hands off the wheel for a more intelligent system that can do these things for you and be able to trust it.
Well, and those internal ones are far more power, right? There's the ones that we do externally, and there's a lot of marketing in that, right? And
There needs
but
to
it's
be.
part of what we do. We have to do that to promote what we're doing. But those internal references where somebody goes, "All right, tell me about the controller architecture. How do really what happens?"
What's
They
been
go,
your experience?
What's been your experience? When did you do that evergreen upgrade, right? And usually we get people telling great stories. Fantastic. JD, last thoughts? You good?
Well, I think from a last thoughts perspective, I think a lot of the reasons why we were able to do some of these things is in the early days of the company, we didn't just go out and hire people who had built other storage systems to come in and build a storage system that was a lot like other things they had built. We hired folks from across the industry to think differently
Right.
about what we were trying to design. And so I think a lot of what we're talking about today and in this entire series is addressing the problem differently and hiring in a great team of folks that had that mindset that enabled us to go do that.
Do I dare do a last story? You made me think of another thing. How dare you? How dare you?
We're
So-
not going to be able to stop you.
Some of the early engineers that came in from kind of a consumer background, I believe it was Kaz that was telling a story about how they were looking at the interfaces for other storage systems, and they were just like,
Yeah.
So this is video, fortunately, so you can see my shocked face, kind of thing. But it was actually like people actually live with this. And it was like, so one of the things that you look at FlashArray UI or FlashBlade, it's dramatically simpler. So we had folks that didn't come in with the preconceptions about all the different knobs and dials and things that you should be able to look at. Like, no, let's start from almost a first principle standpoint of what's actually needed here and what can be simpler.
Yeah, love that. That was actually in the audio podcast series, one of the more favorite episodes I did were, things that storage practitioners have to do that they don't need to anymore, but they're not aware of that because that's just what you've always done. Right.
Yeah.
And things have changed. And that's part of our work here is to educate those that haven't gotten the message yet. More and more have, and that's a good thing. But this was a good one.
Fundamentally making customers' lives better.
Yeah, that's really what it's all about. Well, thank you, gentlemen. Good. It's a wrap on number 3. So we are marching through and having a lot of fun. I hope everybody out there seeing this and hearing this, you're also enjoying both the stories as well as the deep education into the architectural decisions and getting some really good flavor. JD and Andrew prepared quite a bit for this, actually. So you're hearing a lot of things that are very fresh from them, diving back into the history and watching some of the old videos. So some really new insights here, which I really appreciate you all going and getting. As always, tell a friend, tell a colleague, share the program, share the links out. We love when you do that, and we will keep the great content coming for you. And with that, we will wrap. For Pure Storage, for Andrew Miller, for JD Wallace, this is Rob Ludeman saying, don't look back, something might be gained.